Welcome to my course, Continuous Delivery in DevOps with Azure DevOps, the big picture. To support teams to move towards continuous delivery in DevOps, you need a tool suite to ensure that you can deliver software in a reliable, automated, secure, and compliant way. This tool suite is provided by Microsoft and is called Azure DevOps. This course will give you an overview how to use the Azure DevOps tools to implement continuous delivery in DevOps. We will first start with the Azure DevOps boards, where I will show you how this supports the team in their agile way of work. We will look at things like work items, product backlogs, sprint backlogs, and how to visualize your team's work on a variety of boards. Next, we will look at Azure DevOps repos, and then specifically at Git repos. We will look at how you can track the history of your commits and how you can guard your branches with branch policies and pull requests to guard the master branch from commits without a review and build verification. After we have looked at the repos, we will then move to Azure DevOps pipelines. Pipelines provide a way to build and deploy your software. We will look at creating and running builds, CI builds for pull requests, and of course how you can automatically trigger builds and releases the moment you commit something to your version control repository. When producing quality software, you need tools for test automation and the tracking of manual test activities. With Azure DevOps test plans, you can track all test efforts as evidence to regulatory bodies, so you can prove that you tested critical parts of your software. We conclude the course with the use of Azure DevOps artifacts, and we'll look at how we can control the packages that are consumed from outside your organizational boundaries, like for example, node packages or NuGet packages. After taking this course, you have a clear overview of what Azure DevOps tools can do for you and how you can implement continuous delivery and DevOps in your organization with the help of these tools. I hope you join me and take the course Continuous Delivery in DevOps with Azure DevOps, the big picture at Pluralsight. Hi, and welcome to the Pluralsight course Continuous Delivery and DevOps with Azure DevOps, the big picture. In this course, I will give you an overview on what the Azure DevOps toolset can do for you when implementing continuous delivery and DevOps. I will show you the various parts of the toolset, like the dashboards, the boards, the repositories, the build and release pipelines, the artifact store, and the test plans that are available. I will go through each of the individual parts that are available as a separate offering. I will also show you how all the products work together and can deliver a seamless experience that enables you to build a DevOps and continuous delivery strategy in your organization that is secure and compliant by default. My name is Marcel de Vries, and I will be the instructor for this course. When you still have questions unanswered after taking this course, please reach out to me on Twitter or the discussion forum of this course, and I will respond as soon as possible. Let me start by giving you an idea on what we will teach you in this course. We will start with the why and the what. This means we'll have a short look at some definitions and the way of working in both traditional IT software delivery as well into continuous delivery and DevOps. Next we will have a look at the how, and this is where we will go into Azure DevOps step by step. We will start with Azure DevOps boards that will help you organize the delivery of your software product. Then we will have a look at Azure repos. Repos are a vital part of the solution since you need to store your software in a version control system. Azure DevOps provides you with two ways of version control. One is a centralized source control system called Team Foundation Server Version Control, and the second system is called Git. In this course, I will show you how you can use them both, and especially how Git integrates very nicely with the previously described boards to track your changes and provide a way to create a compliant software delivery strategy. Next, we will look at the pipelines. Pipelines are used for both building the software as well as releasing the software. So in this part, we'll start at looking at the DevOps build pipelines, and then we'll look at the release pipelines. The pipeline integrates with all kinds of different source control systems, under which the popular ones like GitHub, Git, SVN, and Team Foundation Server Version Control. After we looked at the pipelines, we'll go into the Azure DevOps task plans. Task plans offer you a way to organize and structure your test strategy. We will conclude this course by looking at Azure DevOps artifacts. In the course, I will show you the individual capabilities of each part of Azure DevOps. To show you the full power of the product, I will also show you how the various parts seamlessly integrate with each other to provide you an end-to-end solution that can really boost the speed of delivery of your team. Since Microsoft takes care of all the integration, you have your hands free on focusing on the delivery of your software product for the customer. By the end of the course, you should have a good overview of what Azure DevOps has to offer for you and any developer that targets any platform. For more details on various products, you can take the separate courses that I built that go in much more detail in each and every product. Let me start with the why behind Azure DevOps. Why would I need a product that has so many different parts for delivering our software? Can't we just keep it simple? Well, actually, Microsoft created a product suite for us to help us navigate the new normal in software delivery called DevOps. You might have noticed that in our industry, many organizations are moving towards an agile way of working. This means that the waterfall approach that we have embraced the past decades is now fading away. We are in a major paradigm shift, and we're moving away from an engineering way of thinking about software delivery towards a manufacturing approach. This means we are now looking at concepts that are used in manufacturing mass goods, like for example cars. In fact, a lot of the techniques that we embrace come from lean manufacturing principles developed by the car industry, which was led by Toyota. Things like Scrum, Kanban, and the end-on code, etc., all are concepts that have been translated into software delivery. We can either use a set of independent tools for your Agile Scrum board or Lean Kanban board with, for example, Jira or Trello. You can use a build tool like Jenkins, TeamCity, Bamboo, and you can find many different tools for release management, like, for example, Xebia Labs Axle Deploy, Jenkins, Octopus Deploy, etc. But with Azure DevOps, you have a tool suite that can be used for all these things and have one secure, fully traceable, and easy-to-use toolset that you do not have to host or maintain yourself. If you compare the traditional way we did software delivery to the modern approach, we see a big difference. Traditional IT organizations approach software delivery as a project. And in modern IT, we look at it from a development perspective. This means we moved from waterfall to an agile way of work. Modern IT organizations have implemented agile as the way of delivering software to the business. I can also state that I most often see that they use Scrum as the agile way of work. In traditional IT organizations, you also see a strict separation of responsibilities, often even split into different organizational units. Especially when it comes to delivering software as a value stream, where everyone needs to collaborate to get things done, you see that this is one of the biggest hurdles to take before you become successful. Modern IT organizations organize around value streams and create dedicated teams to deliver those streams. All people in those groups are empowered to make decisions how we build the software as long as they deliver the required features on time. In traditional organizations, you see a very strict separation between the business and IT. You can think of this as more of a demand-supply organization. The business asks and IT delivers. Often not on time and against very high costs, but it's more or less the model. In modern IT organizations, we understand that the business is IT, meaning that they would be nowhere if it wasn't for the IT infrastructure and operations. So here you see we have mixed teams that have all the disciplines as one delivery team, making the team responsible for success and everybody helping to make everything automated. Even on the requirements part, we use techniques like acceptance-driven testing to make the specifications so clear that they can be tested by automated tools. In traditional organizations, we see we have fixed delivery cycles of about 3 to 6 months. In modern IT, we do not wait for the cycle to be done. We just release any moment we want, since it is nothing more than pushing a button and be done. And finally, a very important difference is that traditional IT organizations reason that IT is a cost center, and therefore run a budget and a cost-driven operation, trying to squeeze the best bang of the bucket, and also often outsourcing a lot of the work as fixed-price requests. In modern IT, we understand that if IT is the business, then we need to ensure that we are on top of this ourselves, and we run a business that is driven by value streams. We need to push out as much value as we can, preferably in a fully automated fashion, adhering to the principles of continuous delivery and DevOps. If you look back at the Agile Manifesto, which is more or less the starting point of the Agile movement, you can see that they already mentioned continuous delivery when they defined the Agile way of work. In the first principle of the Agile Manifesto, they stated the following: our highest priority is to satisfy the customer through early and continuous delivery of valuable software. So if you look at the manifesto, we can conclude that from the moment the Agile movement started, they already explicitly stated continuous delivery of valuable software. So continuous delivery was already mentioned back in the days when the Agile Manifesto was created. Interestingly enough, for most of us, it still seems like a pretty new idea. Continuous delivery is all about creating a repeatable and reliable process for delivering software. You have to automate pretty much everything in order to be able to achieve continuous delivery. Manual steps will get in the way and become a bottleneck. This goes for everything from requirements authoring to deploying to production. We can conclude that continuous delivery is all about creating a repeatable and reliable process for delivering software in order to deliver high-value software to our customers fast. Okay, so now we know what continuous delivery is, but what is DevOps? I love this definition once given by Donovan Brown, who works at Microsoft. He stated, DevOps is the union of people, process, and products to enable continuous delivery of value to our end users. I emphasize the part of the sentence to enable continuous delivery, since it defines the relationship between DevOps and continuous delivery. DevOps is how we change the way we have traditionally worked in IT in such a way that we work from a perspective that all team members carry the success of delivering value to the end users. This means that the way traditional organizations operate with a separate notion of the business, the developers and the testers and its operation will no longer cut it. Now this is awesome, but how do we do all of this? Now let's take the step how to make this all happen and how to do this in a secure and compliant way. Let me introduce you to the toolset of Azure DevOps that is specifically built and designed to help you with the implementation of modern, continuous delivery and DevOps as we just discussed. Azure DevOps is a set of individual tools that will help you with the various parts of continuous delivery and DevOps. The individual tools work together with all kinds of open source tools and commercial tools that are out there. I will show you this in the various demos that will follow. Azure DevOps integrates very well with itself, and that will give you an end result with an additional boost. I will show you this at the end of the course. End-to-end traceable code that is delivered to production in a secure and compliant way, without you needing to build or create the integration between the various parts. Let me go through the different parts of the product one by one in more detail. The product suite consists out of Azure boards, repos, pipelines, test plans, and artifacts. Azure DevOps also has a wiki and dashboard capabilities. Let me start with explaining what Azure DevOps boards can do for you. Azure DevOps boards give you a visual environment where you can collaborate with each other on the work that needs to be done to create a software product. The boards are focusing on providing a collaboration environment that serves the need of a team that is working according to an agile or DevOps way of work. It provides all kinds of ways to visualize your work and work together in an agile way. You use work items to create your specification on what you want and how you think it can be implemented. Every work item card can be customized to your likings with additional fields, colors, etc. Since you can define the card yourself, Microsoft also has collaborated with, for example, Scrum.org to create a template that completely matches the Scrum approach. By selecting this template at the project creation, you have all the things defined in Scrum to track your work and collaborate in a Scrum team. Think about work item types of the type product backlog item, bug, or impediment. It also provides a way to organize this in the form of a backlog or a sprint backlog that contains all the items you want to produce in one specific sprint. You can use the work item types to provide traceability of the work that needs to be done by the team. You can organize this work using an agile planning tool like a backlog of work items. And if you use the Scrum approach with sprints, you also get the ability to create your sprint backlog to track work. You can also configure the board so you can use Kanban as the approach if you don't like to work in sprints. Or you can even mix and match by creating additional swim lanes on the board so you also can combine planned and unplanned work. Let me show you in the following demo how you can use Azure DevOps boards to collaborate with a team that uses Scrum. I will show you the backlogs, the sprint backlogs, the work items, and the way to forecast where we have a few sprints. I also show you how things are traceable against each other, so you can always track which work is done because of what requirement or customer request. In this demonstration, I'm going to show you how you can use Azure boards. So let me start by going to dev.azure.com and then go to my Fluent Byte repository and then go to the big picture. And in this project, you can see that we have all the items in there this is my big picture repository specifically for a Perl site. You can see that we have the boards over here. You can see that we also have the repos. We will have the different pipelines that we can use. And we have test plans over here. Now let me go into boards first and explain you what can we use over there. So when I click on boards, you see a list of work items. And all these work items are definitions of work and all have different type, and per type you can have a specific template. For example, this was a bug, and in this bug you see that there's a specific form that you can use, and in this form we have a set of fields. Now, for example, one of the things we can do is we can add labels here. We can label certain things so that we can query on this later. For example, something has a label acceptance test, or something has a label additional bugs or something, and you can then query on that later. You see here that we have a rich text edit field, and we can also use Markdown for that. Now, when you use, for example, star, and then you do a space, you will see the indenting get started automatically, and we can then fill out that Markdown information there. So it's a very nice editor that you can use to specify what happened. We can set all kinds of priority levels, and depending on the template, you have different fields that you can use in a particular definition. Now, one of the things you see here is that we also have this notion of relationships, and we can create, for example, new related work items. So there might be a parent-child relationship, or something is tested by, or something is a predecessor. So there are all kinds of relationships that we might have between certain work items. I can create here a specific type of work item, so something is tested by a test case, and that's the way we create these new items. Here you see that there's already a link to a feature, and this feature then has a definition and has a relationship to my particular work item. You see that there might also be a date picker in there where we can select a date where we would like to start working on this feature, for example. The other thing is that every work item always has this notion of history, so we can see what happened and who made changes to what. And you can then see additional information about the history, and every detail has been captured, so that way we can always comply to regulations if we can show who changed what and why. Now here you see also the additional linked items. So there's a lot of information on every form that we have. Now here you see the list that we have. And what we can do is, when we look at a detail, for example, of task, you see that we also here have a rich text edit field, the priorities, etc. So based on the type, you get a different form. So we already saw the feature, we saw the bug, we now have seen the task. Now there's another way of looking at this, and that is based on the backlog. And backlog is a list of work items of the type product backlog. And you can drag and drop here to set the priority. So for example, I have a bug on my backlog. Now I could drag it and give it a higher priority. Now one of the things that I can do is I can also click on planning. And with this, I can then say, I would like to plan a certain piece of work, and I drag it then into one of the sprints that I might have. So this is a nice way on planning your work. And now you saw that I just added to sprint 2 a bug, and this data has now been captured, and this way we can now track all that work. The other thing that we can do is we can then say, I would like to see relationships. So now you can see that the bug has been related to a check-in from the phone and back to the smartphone experience, and that is the epic. So you see different hierarchies here that we can create, and normally you use this notion of an epic, a feature, and based on a feature we have stories or product backlog items. You can see that I can drag and drop items here, and by dragging and dropping them in the hierarchy, I create a parent-child relationship again. So all these kind of ways of moving stuff around and relating to each other can be done just with a blink of an eye and just dragging and dropping. The other thing that I can do is I can do some forecasting. So for example, if I know that my team has a certain velocity in effort, I can then define here that I, for example, always have a velocity of 30. Now this 30 will give me a forecast where I might end using my sprint planning that I have today. So let me turn forecasting off again. And let me turn on mapping. Now with mapping, I also can create relationships. So here, for example, I can use this product backlog item and drag it on a feature that I have. And this way we create a parent-child relationship between the feature and the actual product backlog item. So this way we can then very nicely create order in all the work that we have, do some planning, and ensure that things are related to each other. You can also toggle on and off what you would like to see. So now I would like to see only the backlog items. And in my definition, I defined that a bug is also work that I have. Now an alternative view of this is a board. And these boards are often used as a visual radiator and sometimes projected on a screen in a room so people can have a look at it. You can see that you can just drag and drop on the board to move items that you are at the moment are working on. For example, this bug now has been approved. It's an actual bug, so we can work on it. You can also turn on live updates on or off. This means that when you make a change, somebody else will see the change as well. There are many things that we can define. So for example, on the product backlog item, we can list what is shown on the info card. So for example, what I could do is say, for a bug, one of the things I would like to do is add a field on that card, and that field would be, for example, the priority field. Now when I do this and save and close this, you will get a live update, and all the bug items will now have a priority on there. And the nice thing is you can create inline changes there, so you don't need to open the form and then make a change. You just do it on the board itself. One of the other things is that you can create styling rules. So in terms of the visual radiator, you can now create something which is something with a high priority, for example. Now if you look at high priority, I would, for example, make that green so that it really lights up on my board. And how does it light up? Well, I can use a specific field. Let's say that the priority field needs to be a certain value, the value of, let's say, 1. So all items with value 1 now need to become green. And you see that this item now has a high priority, is green. When I change this priority to 1, you will see it also becomes green. So that's the way you can use visual styling to create your board the way you would like to be it, so that you can just see how the team is performing. The other thing that you can see is that you can see how the board is laid out in terms of the different lanes that we have. Or the different columns that we have, sorry. Now every column can be split also in doing and done, which is more or less a meta state. I'm doing it and it's done in approved, because sometimes you have people that approve stuff and people that build and test stuff, and so that's the way you can then do doing and done within a particular column. The other thing that we can do is we can say, okay, for example, let me turn off this splitting of columns, by the way. The other thing that we can do is we can also define what we call swim lanes. And this is nice when you have, for example, a thing what we call an expedite lane. An expedite lane is where we drag in items that we need to be doing now instead of the priority of the backlog. So for example, I could now drag this card on this expedite lane, and that way everybody knows that this is work that needs to be done now, because it might be an incident that we're working on or something that needs to be done, a live site incident, etc. Now you can also look at this from a sprint perspective. So we were looking at this from a backlog perspective, but now from a sprint perspective, this is what we're working on at the moment. And then we look at product backlog items and the tasks underneath it. You can see that we can drag and drop here as well, making it a priority on my board also. So the priority on the board is a priority of the sprint backlog that you maintain in the sprint tab. Now one final thing to show you is that we can also define queries. And those queries go into searching in the work item types that we have, in the work items that we have in our database. And we can, for example, search for bugs that we might have that have a state that is not equal to, let's say, a done state, because it's still an open bug. And when I run this query, you will see that I have all the open bugs that are momentarily in the system. Now you can also make some more complex queries. So for example, let us have a look at all the product backlog items. And I would like to do a so-called hierarchical query. So for this, I will say that I would like to use a work item and directed links. And then I can see the relationship. And when a work item has a relationship with a work item type of, for example, the type, let's say test case, then I can query the items that have test cases associated with it. Now this is nice that you can see which work items have test cases. But another thing, and that is a not query that we can define, say, well, give me all the work items that don't have a type of test case associated yet. We can do it like this, so return all the items that do not have the matching criteria. And this way we get all the items that do not have a test case associated. And now we know all the work that needs to be done by our test engineers to define test cases, for example, for these items. Now I can save this query. And this query can be saved to my queries. I can also save it to the team's query so everybody can use that. I will save it as backlog items without a test case. And the moment I save that, I can then reuse that. So now when I go to my queries, you will see that my query is over here. And when I click it, I can then actually look at this list without running the query by hand. It will be executed immediately. And with this, I've shown you how we can use Azure boards. The next part of Azure DevOps is Azure DevOps repos. Repos are the place where you can find source control tools. Azure DevOps repos provides two primary types of source control. First, they have the option to use a centralized source control system that the industry has used for a long time. The flavor they have is Team Foundation Version Control, better known as TFVC. TFVC is used less these days, but it's still there for many years to come, and it's not going away soon. Although TFVC was Microsoft's most predominant version control system, this was also very heavily used internally by Microsoft product teams when building the software products. You now see the industry is moving rapidly towards a distributed source control system. Therefore, the second type of